Alright, so today we're going to start 7.4. I know it says 6.5, but it's 7.4. And we're going to use the proportionality theorems in triangles. So our triangle proportionality theorem states if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. So if EB is parallel to DC, then this part of the triangle AB over BC is equal to the left side AE over DE. So the parallel line that goes through the triangle divides the sides proportionally. Okay, now we have our first example. Find the length of the segment. So we have two parallel lines, so we know that the sides of the triangle are going to be proportional. So what is the proportion we can set up? Okay, remember, we have to keep it consistent. So if we do this little part over 9, then we have to do this little part over 10. So x over 10. Now how do we solve for x? Cross multiply. So we get 40 is equal to 9x. And we just divide by 9. So we get x is equal to 40 over 9. All right, next we have the converse to the triangle proportionality theorem, which states if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So this is the same thing we did before, but in reverse. So if AB over BC is equal to AE over ED, then EB is parallel to DC. So if our sides here are proportional, then the line that goes through the triangle EB is parallel to DC. So in our next example, we have to verify that MN is parallel to KL. So what do we need to do in order to verify that these lines are parallel? See if the sides are proportional. So we need them to have the same proportion. So we can set 42 over 21 and see if that's equal to 30 over 15. So I put the top part of this over the bottom part here, and then I did the top part here 30 over the bottom part 15. So it's important that we keep it consistent. Now there's two ways we can prove that these two are equal. We can just simplify our fractions, or we could cross multiply and see if they're congruent. What do you think would be easier to do? Simplify. So how do we simplify 42 over 21? It simplifies to 2 over 1. And what about 30 over 15? 2 over 1. So do these have the same proportion? Yeah, they're equal. So are the lines going to be parallel? Is MN parallel to KL? Yep. Ready for the next example? When you cross multiply, so 42 times 15 is 630. 21 times 30 is 630. So when you get that they're equal, it means that they're proportional.
So what would be the answer if we cross multiply?
All you have to do is verify, so you just need to either show that these are equal here or show that this is equal here.
I did the cross multiply and I got 630 divided by 630.
Yeah, so exactly. Okay, next one. CD over DA is equal to, so what proportion is CD over DA? What is that equal to? Austin. CE over BE. Perfect. Good job. If CD is 3 and DA is 6 and DE is 3.5, then AB is what? What do you think our proportion that we need to set up here is going to be? Perfect. So 6 over 3 is equal to x over 3.5. And the reason why it's x over 3.5 and not 3.5 over x, because this is x, AB is x. That's what we're trying to find. So this is part of the big triangle, this big triangle. And since 6 is part of this big triangle too, and 6 was on top, we need to keep x on top. So we could also write this as 3 over 6 is equal to 3.5 over x. This would be the same thing as this. So either way, as long as you keep it consistent. So we're either going to have both the 6 and the x on top or both the 6 and the x on the bottom. Let's solve this one. What do we need to do to solve for x here?
Times 3.5 times x.
So we cross multiply. So 6 times 3.5 is going to be equal to 3x. So what is 6 times 3.5? 21 is equal to 3x. What is x going to be? 7. So AB is equal to 7. Yes.
Can you see how it's going 3 and 6, so it's times 2. Can you just multiply DE times 2 gets 7?
Yeah, perfect. Because we just need to see what proportion this has, because this one's going to have the same one. So since 6 is 2 times bigger, you can just see that x is going to be 2 times bigger. That's awesome that you saw that.
Wait, what did you point out?
So since 6 is twice as big as 3,
Yeah.
x is going to be twice as big as 3.5. So he just saw the proportion right away and just multiplied by that proportion, by that ratio. Okay, now let's do part C. If CB is 12, so this whole thing here is 12. EB is 8, and CD is 6. So we can cross these out. CD is 6. Then DA is equal to what? So DA is going to be our x. That's what we need to find. If CB is 12, what is EC? It's 4. Because this segment plus this one is going to equal this whole thing, 12. So we just do 12 minus 8 to find EC. So now what proportion can we set up?
12 over 8 equals x over 6.
No, because 12 is talking about that whole long side. So we could do 12 over 8 is equal to x over x plus 6, because then we would have to be talking about this whole long side. But an easier proportion would be what? Kevin, you want to try?
No, what I did was I saw that 4 was half of 8, so I figured that that DA would be half of 6.
So what'd you get for x?
Yeah, X or
DA.
DA.
Okay, let's set a proportion and see if you're right. So what proportion can we set up?
8 over 4 equals x over 6.
Perfect. 8 over 4 is equal to x over 6. And now we can cross multiply.
You got 4 because it's half of 8, or because it equals 12 over 4?
Well, let's see if he's right. So what's 6 times 8? 48. And that's equal to 4x. So then we divide by 4. So what do you get for x? 12. So x is equal to 12. So I see what you did, Kevin, but you did half instead of multiplying it by 2. That's why it's good to set up the proportion, even if you see that ratio right away of what it could be, because Kevin saw that EC was half of BE, but it's good to still set up the proportion to make sure you know you're doing it right.
So that's how I got 4, because it was half of E.
Yes, but he took half of DC, but we need to multiply it by 2. So x is equal to 12. DA is equal to 12. Okay, any questions on this one? Okay, our next theorem states if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So we're going to have the same proportions here as we did in the triangle. So BC over CD is going to be equal to AF over FE. So it's just the same thing as the triangle we were doing earlier, but now we have 3 parallel lines that are cut by 2 transversals. And they're just going to have the same proportion. Okay, let's look at some examples. If A is 2, B is equal to 3, and C is equal to 5, then D is equal to what?
6.
What's the proportion we can set up? 2 over 3 is equal to 5 over x. Now what do we do to solve for x? Cross multiply. 2x is equal to 15. Then we divide by 2. And x is equal to 7.5.
Can you leave it as the 2
Yeah.
over 2?
Yeah, you could leave it as a fraction. So D is going to be 7.5.
Proportion, does it matter if you put 5 over x or x over 5?
It matters because it's important that you keep it consistent. So if we do the 2 on top, we have to do the 5 on top. So if you did 3 over 2, so like the bottom part on top, so if we flipped it and did 3 over 2, we could say x over 5. Okay, let's look at B. So if A is equal to 4, B is equal to 8, C is equal to 5, then C plus D is equal to what? Well, first, what do you think we need to find? X. So we need to find D, and then we can just add C and D. So what proportion can we use to find D?
4 over 8 equals 5 over x.
4 over 8 is equal to 5 over x. So now we can just cross multiply. So we get 4x is equal to 40. And what do we get for x? 10. So since D is 10, what's C?
It's 18.
What's C? 5. So what's C plus D? 15. Any questions on this? All right, our last theorem that we're learning today. If a line bisects the triangle, then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So if a line bisects the triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. What does it mean to bisect? Cut in half. So this line CD is cutting angle C in half, hence our 2 arc marks that we have in here. So in order to use this theorem, we need to have those 2 arc marks. And our proportion is going to be AD over DB. So the side that's being cut in half is our first proportion is equal to CA over CB. So our side that's being cut in half is our first proportion, and then the sides of the triangles are the other 2 things in the proportion. Okay, let's go to our example. So find x. What do you think we need to find before we find x? The missing side. So x is this segment that's 10 plus this one. So let's call this missing segment y. So what proportion can we set up here?
12 over 10 equals y over 24.
What-
I mean, sorry, 10 over 12 equals y over 24.
What was the theorem that we said before, Sydney?
10 over x is equal to 12 over 24.
10 over y, right, because we're just finding this missing part, is equal to 12 over 24. So since 10 is part of this triangle to the left and 12 is part of the triangle to the left, we have to keep those two on top. Now how do we solve for y? Cross multiply. So we get 240 is equal to 12y. We divide by 12, and what do you get for y? 20. So y is 20. So then what would that make x? 30. Perfect.
Did you look at it like how 12 is half of 24, and then just like that 10 is half of 20?
Yeah, you can, but just be careful when you're looking at it like that because that's how mistakes happen. So it's easier just to show your work, set up the proportion, make sure, like you could see that right away y is going to be 20 because it's twice as much as 10, but just to be sure, double check your work, set up the proportion, and see if you're right. Okay. All right, next example. Using the triangle angle bisector theorem, find RV and VT. So what proportion are we going to set up here?
X plus 2 y 2x plus 1 equals the name 10 y 14.
Perfect. Awesome. So now what do we need to do to solve for x?
Do the
Cross multiply. Same thing we've been doing before. So now we have 14 times x plus 2 is equal to 10 times 2x plus 1. How do we multiply this 14 times x plus 2? Distribute. So we need to distribute the 14 times the x and times the 2. So we get 14x plus 28. What do we need to do to the right side? The same thing. We need to distribute again. So what do we get on the right side? 20x plus 10. Now what do we need to do to solve for x?
Subtract 14x from 14 and then subtract 10 to 28.
So we get 18 is equal to 6x. So what do we get for x? Perfect. What's the question asking us for?
Find
RV and VT. So we just need to plug x back in to both of these. So for RV, we get 5, and VT, we get 7. Any questions on this one? Okay, our next example, find the length of each segment. So we're looking for JG here. What proportion can we set up?
20 over 30 is equal to 12 over x. I mean 11 over x.
Perfect. 20 over 30 is equal to 11 over x. What do we need to do to solve for x? Cross multiply. What's 11 times 30?
330.
So now we divide both sides by 20. And what do we get for x?
$16.5.
16.5.
Can we leave as a fraction?
You could leave it as the fraction 33 over 2, because that's this simplified, right? So just as long as your fraction's in simplest form, you can leave it as a fraction. Okay, let's do number 2. What proportion can we set up here? Allie.
X plus 5 over x minus 5 equals 12.5 over 7.5.
Perfect. X plus 5 over x minus 5 is equal to 12.5 over 7.5. So we need to cross multiply. And we get 7.5 times x plus 5 is equal to 12.5 times x minus 5. What do we need to do now? Distribute. So we get 7.5x plus, what is 5 times 7.5?
37.5.
Perfect. And that's equal to 12.5x minus 5 times 12.5.
Yeah.
62.5.
Yeah, that's what I know.
So now what can we do to solve for x?
Minus 7.5x to 12.5x.
So we get 100 here. Is equal to, yes,
That,
is equal to 5x.
x is 20.
What'd you guys get for x? 20. Our question's asking us for SR and ST. So we just need to plug it back into SR and to ST. So we have 20 plus 5 here, which would be 25, and 20 minus 5, 15. Good job. All right, one last example. Yay. Verify that EB and CD are parallel. What proportion do we need to set up? So, wait, say that again?
12 over 18 equals 9 over 13.5.
Perfect. We could also, so we could also set it up as 9 over 13.5 is equal to 12 over 18. That would be the same. So what can we do? Should we simplify it or cross multiply?
I did cross multiply.
Cross multiplying would probably be easier here because we have a fraction on the bottom. So let's cross multiply. Since you guys have a calculator now, what's 12 times 13.5?
162.
162. And what's 9 times 18?
Same thing.
Same thing, 162. So are BE and CD parallel? Yes. And our work here just tells us this is our work that verifies that they're parallel because they have the same proportion. All right, so this was 7.4.